Hi, I'm Jeremy with SOLIDWORKS, and today we're at Ecco in Boise, Idaho, where they design and manufacture backup alarms and amber warning lights. Today we're going to see how they use SOLIDWORKS simulation tools to validate and optimize their designs and reduce their overall product cost.
Strength is an important part of every design here at Ecco. All of our products are mounted onto commercial vehicles, which typically is a very extreme environment. Whether it be vibration, temperature, they're under a lot of stress. So we're going to use the SOLIDWORKS simulation tools to simulate those environments. And in our designs, we not only want to make things strong enough, but we also want to optimize the design so that we don't have any wasted material. And in doing so, that allows us to provide the most efficient solution to our customers' problems.
Simulation has been very helpful because LEDs produce a lot of heat, and we have to be able to get that heat out of the LEDs so that the lights continue to function. We use flow simulation to model up aluminum heat sinks. Typically, we're able to input the wattage produced by an LED or an array of LEDs, and we can take that information, run a number of different iterations as far as the number of fins that we want to use, the spacing between fins, how tall the fins are, and really get an idea of, how big does this heat sink have to be? Can we get more light out of a particular product if the heat sink's big enough and it's doing its job?
Nick, I noticed we had a couple examples of this part here. They look like they're 3D printed parts. Can you tell me a little bit about them?
Yeah, so in the 12 series design for this, what we call work light / alley light, we had to go through a few iterations to dissipate the heat. So we knew our heat source, that was a fixed amount. And with that, we could prototype things up and measure it, but we didn't know if that was the best that we could do. So this was our initial design based on other heat sinks that we have and have seen, but found that it wasn't performing as well as we wanted. We spaced the fins out because of SOLIDWORKS flow results. We achieved lower temperatures. So by spacing the fins out, we got lower temperatures, and then finally, just based on tool design and overall aesthetics and fit, came out with a final, more refined design that used less material and achieved better results overall until we got to the tooled final production piece and achieved a lot cooler temperature, so it ran more efficiently and actually used less material too.
The product I've been working on is the 630 glass-filled nylon alarm housing, and this is a heavy-duty product. Initially, this product was in a metal housing, and the sheet metal needed welding. It was labor-intensive and it was expensive, and so we wanted to look for a way to reduce cost and also eliminate some of the assembly parts. So the design idea was to take that same shape, but make it into a single molded part of glass-filled nylon. Well, we were able to validate by making a part out of glass-filled nylon, adjusting the thickness to find out, well, how thick does this have to be strong enough? Where can we add fillets so that we don't have any stress points? What kind of force is this alarm going to see in regular use?
John, why don't you explain to me a little bit about what's going on with these components?
This was our part previously. This is a foot for our light bar. It's made of sheet metal. It's expensive to make. It has to be formed and bent, and it's also subject to corrosion. So we decided that we wanted to change. So what we did is we started with a basic design, was able to print it using SOLIDWORKS, make a model and print it on our FDM printer, and then from there tweak the design if it means adding fins to make it more structurally sound, adding other features for more aesthetics. And so we went through a number of iterations, adding some aesthetic things, moving ribs around to get that final part until we had an actual tooled part made of glass-filled nylon. We use simulation almost from the outset. Once a basic concept is there, and then as you get farther along, keep running simulation, check to see, is it going to adversely affect what I'm trying to do here, and then one last time before the part goes out for tooling.
SOLIDWORKS' suite of simulation tools allows us a high level of confidence and the ability to do designs that we would not otherwise be able to do.
So as you've seen, Ecco uses a host of SOLIDWORKS products to design their parts right the first time. To learn more, explore the rest of the videos in this series or contact your local SOLIDWORKS reseller.